Hi, Sal.
Hey, Britt.
How are you?
Good. Looks like we have a game going on here.
Not a game, yeah. I kind of a challenge question for you. What I did is I put 1 grain of rice in the first square.
That's right.
There's 64 squares on the board.
Yep.
And at each consecutive square, I doubled the amount of rice.
Mm-hmm.
How much rice do you think would be on this square?
On that square. So let me think about it a little bit. Actually, I'm going to take some. So here you have 1, and we multiply that times 2. So this is going to be 2 times 2. No, 2 times 1. What am I doing? Now this is 2 times that one. So this is 2 times 2. Now this is 2 times that. So this is, okay, we're starting to take a lot of 2's here and multiplying them together. So this is 2 times 2. I'm trying to write sideways. Times 2. So this one is going to be 5 2's multiplied together. This is going to be 6 2's multiplied together. This is going to be 7 2's multiplied together. 8 2's multiplied together. So 9 2's, 10, 11, 12, 13. So all of this stuff multiplied together. 8,192 grains of rice is what we should see right over here.
And you know, I had fun last night. I was up late, but there you go.
Did you really count out 8,192 grains of rice?
More or less.
Okay. Let's just say you did.
What if we just went, 4 steps ahead, and how much rice would be here?
4 steps ahead, so we're going to multiply by 2, then multiply by 2 again, then multiply by 2 again, then multiply by 2 again. So it's this number times, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's going to get us like 120, like 130,000 or around there.
131,672.
You got a lot of time last night. We're not even halfway across the board yet.
We're not.
I mean, this is a lot of rice there that you could throw a party.
What about the last square? This is 63 steps.
We're gonna take 2 times 2, and we're gonna do 63 of those. So this is going to be a huge number, and actually it would be neat if there was a notation for that.
I didn't count this one out, but it is the size of Mount Everest, the pile of rice, and it would feed 485 trillion people.
But I have one question. I mean, this was a little bit of a pain for me to write all of these 2's.
So was this.
If I were the mathematical community, I would want some type of notation.
You kind of got on it here. I like this ... and the 63. This, I understand this.
Yeah, you could understand this, but this is still a little bit too much. What if instead we just wrote?
Mathematicians love being efficient, right? They're lazy.
They have things to do. They have to go home and count grains of rice.
Right.
This is
That one.
Yeah. So that is take 63 2's and multiply them all together.
This is the first square on our board. We have one grain of rice.
Yep.
And when we double it, we have 2 grains of rice.
Yep.
And we double it again, we have 4. And I'm thinking, this is similar to what we were doing. It's just represented differently.
Yeah, well, I mean, this one, the one you were making, right, every time you're kind of adding these popsicle sticks, you're kind of branching out. One popsicle stick now becomes 2 popsicle sticks. And then you keep doing that. 1 popsicle stick becomes 2, but now you have 2 of them. So here you have 1. Now you have 1 times 2. Now each of these 2 branch into 2, so now you have 2 times 2, or you have 4 popsicle sticks. Every stage, every branch, you're multiplying by 2 again.
I basically just continue splitting, just like a tree does.
Yep.
Now I can really see what 2 to the power of 3 looks like.
And that's what we have here. 1 times 2 times 2 times 2, which is 8. This is 2 to the 3rd power.
When I see 2 to the power of something, let's just say n, n could also be number of steps up this tree. I could think about it that way.
Yeah, you could view it. I guess one way to think about it is how many times you've branched. But that tree there is actually even more interesting.
I don't think this counts because, again, like this branch is 4 times at each branch.
Well, I guess why not? I mean, well, it's different. It's not going to be 2 anymore. So the first one where you haven't branched yet, this is going to be 4 to the 0 power. You've had no branches yet. This, you branched once, so now this is 4 to the 1st power. You have 4 branches now.
This.
And now each of those. So now you've branched twice, so now this is 4 to the 2nd power. So yeah, the base, or what's called the base when you're taking an exponent, this 4 right over here, this is how many new branches each of the branches turn into at each of these, I guess, junctions, you could say.
Let's call them junctions.
Junctions. You haven't branched yet. Here you branched once, and here you branched twice.
This is interesting. This is also why when I look at a tree, there's thousands of leaves, but just one trunk. And when you actually go up and you look inside the tree, it only branches, 3 or 4 times.
And that shows the power of exponential growth.
Yes.